Please like and share this video so that maximum number of engineers may be benefited. Also, please subscribe to YouTube channel to receive the updates about the future events and to receive notification when we go live. If you want to receive regular updates related to live technical discussions, online courses, etc. through email, then you may register at a link showed on the screen.
Hello, good evening, and welcome to this unique live technical discussion series. And today we are going to focus our discussion on scope related to geotechnical investigation. So we have received many interesting points through the registration form, and many of the points were pertaining to interpretation of the soil report also. So those points we will be talking, or rather we'll be covering in the subsequent sessions as and when time permits. So today's session we will be focusing exclusively on, let's say, on the scope related to geotechnical investigation. Okay. And right now, this stream is live on YouTube, Facebook, as well as on LinkedIn. And I have just flashed the address of the YouTube channel. If you want to join the session through the YouTube channel, you can join through this. And we'll be having upcoming live discussion that's on 18th March 22. So we are planning it on the subject structural audit. And Dr. Abhay Gupta has already joined with us in this session also. So he will be joining for that session of 18th March 22, along with Mr. Amandeep Garg. So good evening, Rajan. Good evening, Srinivas Gupta. So you all will be able to interact with us through the live chat during this session. So please feel free to share as many questions, discussion points pertaining to geotechnical investigation. And we'll be starting a unique online course related to earthquake resistant design, which will commence from 17th March 22. So Dr. Ashok Jain and myself will be conducting this course. So the link is mentioned on the screen, which is sqvconsultants.com/eq-str002. So registration is open. If you are interested, you can visit this link for more details. Okay, and you all are requested to share this video into the relevant group so that we can have participation of larger number of engineers. Okay, so as we discussed today, we will be focusing on the scope related to geotechnical investigation in our entire discussion, and the points whatever we have received related to interpretation of the soil report, or let's say if there are certain problems with respect to the foundation type, etc. So those points will be taking up in the subsequent sessions as and when time permits. Okay, so with this, now let us invite our expert team on the screen for a very interesting discussion related to scope of geotechnical investigation. Okay, welcome Umesh sir, and very warm welcome to this live technical discussion series, sir. Welcome Sandeep ji.
Hello.
Yeah, good evening. Yeah, welcome Suhas bhai.
Hello, good evening.
Yes, good evening. Okay, so people are just joining right now. Okay, so let us spend a couple of minutes before we actually getting started. Okay, welcome Kishore Behra. So very good evening. So the total points when we were scrutinizing whatever we received through the registration form, the number reached more than 200 to 300 odd numbers, and that was the numbers which we received let's say before 3 days of this event. So after that, we have also not started looking into those points. So there are many number of points which we have received. Of course, all points are not related to the scope of geotechnical investigation, but the points are related to interpretation of soil report. And let's say if there are certain problem with respect to foundation system, let's say when to go for pile foundation, open foundation, raft foundation, etc., etc. So those all points also we have collated, and then we will be attempting to arrange such kind of a live discussion in the future as and when the opportunity arises. Okay, so before we begin our live discussion, I'll request Umesh sir to share his point of view related to scope of geotechnical investigation. Yes, yes, sir. Umesh sir, over to you.
Thank you, Bhavin. Thanks
Yeah,
a lot.
sir. Yeah,
Uh, Having been all the time in the projects, uh, it's elephant and seven blind men when you ask any investigation, whether it is soil, concrete, or when we do a basic study report, whether on water, water transportation. All of us have such a different views and different requirements. uh, Quite a few times we do not appreciate the other's requirement. We continue to hold back our views very strongly. So it depends on the nature of project, kind of project that you are involved, and it's an extremely difficult task to get an enlightened client who listens to you. Most of the time, you have a problem because there are not many enlightened clients. I would rate, having done over last 50 years so many projects, to be very honest, I found only 7 clients who were enlightened, who were willing to talk to you, who are willing to listen to you. Otherwise, you have to do what they say because they think that they are paying you. And they know better because their project department, headed by either a director or a president or whoever they are, they think that they have done much more than what you have done. And their requirement, they know it better. And to some extent, they are right. Because quite a few times I have found that what they really require is a very small thing, but we make a big issue out of that. And quite a few times, you are right. I agree with Sandeep when he said you need to do holistic approach when you do a ground evaluation and not really geotechnical investigation. I think that was very wonderful statement. Um, like sometimes when you have a very small house to be done, like in our structural engineering group on the WhatsApp, a person who is, at least in this forum you talked about ground plus three. I remember in other group there was a young girl who wanted to build a house in a village in Meghalaya, and she put a question in the group: how do I go about to decide what kind of foundation should I have? And as usual, we are all very knowledgeable people. We are highly qualified. We are updated knowledge. And everybody wrote what the investigation she should do and all that. She said the nearest village is 15 kilometers away. Nearest town is 150 kilometers away. Nearest college is 200 kilometers away. Where will I get this? And it was 600 square foot house on a ground floor. So sometimes our knowledge really doesn't allow us to advise those who really want it in this sector. We are very good when it comes to, if you look at the statistics, it's about 1.8% of the buildings in India are above 10 stories. Above 4 stories, it is only 3.5%. Balance 95 to 96% are ground plus 3 structures or less than that in India, including a company like Ultratech, which is one of the biggest cement companies, and hence the RMC. In a residential sector, they sell 75% of the ready-made concrete. Balance 25% goes in the infrastructure and so-called high-rise buildings. And whatever we are trying to talk about is really for the people of those 1.8% or 3.2%, but we are not really trying to address 95% of the people of what can be done. I'm sure we can all rise to a very high level, but can we have, like as they say, music? Can you sing in kharja? It's not just high pitch, in a low pitch. And we are damn good at high pitch, yes. Whether it was Vincent Joshi or Balmurali Krishna or anybody. But how many of them could come down to a very low pitch and still deliver clarity? And when you look at it, some of the projects like a power plant, as he said, when we did first time Koradi thermal power plant, and we had done, it was a turbo generator, steam generated, and when we dug for a borehole, the drill went down straight, and they were exactly where we had planned our turbo generators. Everywhere there was a tunnel because it's a perfect plateau with a lava flowing and a tunnel. And it was a surprise. So we had to shift our master plan, redo the things, relocate the system. And so many things happen. I agree. Or on a very small site, even in Bangalore, I live in Bangalore, a very small site. There are 4 kinds of soil: clay, rock, sand, and a mixed soil. And it's one building per site. I'm not talking very large site, maybe 100 feet by 100 feet or 150 feet by 150 feet. That's all. And how do you really design the foundation when you do that? Because rock is absolutely strong. Soil, clay is there, sandy is there. How do you really arrive at it? So I think we also need to talk about at a mortal level, if I may say so. How do you really tackle a problem? Like I remember Terzagi's statement when he started, and we have been using this on a smaller site or when on a bigger site also when everything is done. We used to take a crowbar, drop it, hold it in the middle, drop it from the eye level, allow it to fall free, measure the penetration, and then come to a conclusion of what is acceptable bearing capacities. This used to work well in the friend circle where they were doing some buildings, ground floors, like Bangalore was a bungalow earlier, now only buildings have come. So how do you really assess what should be the foundations and things of that kind? Or when you go to a very large site, like some of our sites were 2,000 acres, 3,000 acres, and when the extents are very large, you do take dynamic cone penetration tests, identify the N values. You don't really collect the bore logs. Sometimes you collect the bore logs to identify what kind of profile of soil you may get. But a place like Noida, I think soil seems to be uniform quite a lot because most of the sites where we did work 100 acres or 200 acres or 300 acres of uh, buildings, and you used to find the soil is almost similar wherever you take the borehole. So sometimes you feel you specify based on a distance of number of boreholes. I think it's a wrong approach. It should be based on a master plan. And in a master plan, how you really get your buildings. And if you do initially in first phase some bore logs, you understand what can be expected. And unexpected will continue to be there, and Peter's principle will continue to be there, and it will give you a surprise. But that's where the rest of the things will come. And hence, I think we should be able to talk at a much broader level, though we are all capable of talking at a very high level, we can certainly solve complex problems. We can certainly solve difficult situations. But can we also answer simple questions, or do we make it them complex? And that's where I would say we need to understand when you write the scope, you need to understand the client's requirement, your requirement, project requirement, and the entire system behavior, and then identify what you want. Like one school of thought doesn't believe in SPT values at all. In fact, when there was a TC20 committee which was formed internationally when we met in Delhi sometime about 30 years back, the SPT is to be removed. You cannot take N value because of the various aspects, and that sometimes seem to be true. And there are quite a few soil consultants in India who do not take SPT values at all. They say, no, we don't believe in it. Anyway, I'm not knowledgeable. We have Suhas, we have Sandeep, Dr. Shukla will join. I think they'll be able to throw more light because I'm only a civil engineer who has been always in the project and not really specialized in any field, nor I have any expertise in any area. Thanks, Bhavin. Thanks for giving the opportunity to speak.
Thanks a lot, sir, for making opening statement related to geotechnical investigation. Now, can I go to Suhas Bhai to share his quick perspective, like what common problems structural consultant is facing when freezing the scope of geotechnical investigation at a very early stage of the project? Yeah, your mic is muted. Yeah, yeah. Now it's okay.
Good evening, all of you. Thanks,
Yeah,
Bye.
yeah.
I'm a structural consultant having my field in high rise and industrial areas. So, in high rise, what happens previously before earthquake, the trend of getting investigation of soil is very less. And due course, we understand that it is very important aspect of getting each project a soil investigation. And now the law is also passed for this, but sometimes people are reluctant to do this. There are few reasons behind that. General notion of builders are that the soil is everywhere is good, means they say that every soil is a good soil. When you just go on site, are sir, this is very good soil. But what do you mean by good soil? Means it should be investigated that even the yellow soil have a cohesion, even the brownish soil has a very different characteristic. And this is not your subject, or this is not a subject of a civil engineer. This is a special, is subject of a geotechnical engineer, who will give you the blood report like report, that what this soil mean to you, what this soil will be behave in different loading conditions, what this will help you in foundation, and what you should be cautionary about doing work in such soils. So soil investigation awareness is getting developed, but these are the aspect. The concept of contractor to the soil is he is not aware sometimes when he is digging the soil for two basements. Many times I have seen that they are not taking due care of the soil investigation is based on different parameters, and they will not only give you the soil bearing capacity. Previously, the concept of soil investigation will stop at the soil bearing capacity. Kitna vajan legi, bas, that's it. But there are few other aspects, like whether you need to give a support before excavation, or you need to go for a some specific precautions before excavation. What will this the excavated pit is now very large, of two basement or something more, and the areas are very large. And if in rainy season, what will happen to this soil and these foundations during construction, what difficulty you will encounter. uh, to come out of this soil and retaining wall, etc. work. All these are the necessity answers to be given by geotechnical investigation and geotechnical engineer, so that the safely commencement of basement work and long lasting strength of building will be achieved. Sometimes what happened, the along with the soil, uh, means soil, you need to also investigate the presence of water. Different uh, type of waters are there may be some stagnant water, there may be a intermittent seasonal water, there may be sometimes what happened, there is a strata which is like a disc under your foundation. So all the water of surrounding area will gather there, and you need to solve that also. Sometimes the pore water pressure is very high, which affects the foundation. So only soil bearing capacity investigation base is not enough. We need to investigate at very different parameters. And yes, there are some uh, varieties of soil. Sometimes what happens in nearby building, the soil is very good, but it may be possible that before few hundred years there is a lake or some depression found, and the soil is of filled up soil, and immediately within few meters the soil characteristics are changed like anything. So number of borelog according to theory is not only enough, but practically we need to ascertain that to your basic site, or to your history of this land, how many number of borelobes are important. I will give you one example of my experience, that in one area I have found that there is not a proper soil investigation carried out. The results are not justified by me, means it is some absurd. So I gave another company to investigate that same area. The site is very small. Very small means hardly 20 meter by 30 meter. But the second soil investigation person has come out with the very different results. So again, I am both are a very competent person. So according to law, I need to go for only one bore law, but I take out 3 4 bore laws, and the area gives me very different results. So I decided to excavate everything up to the required depth and go for a raft. That was my decision before understanding, to find out the what is the magic in the soil. Then I found out that there were a very old river bank structure located under the soil. Nobody knows all this. When we excavated, we found that there is a wall of masonry of width more than 2 meter, 3 meter found there. The one side of the wall, the soil is very different. The another side of wall is soil is very different. So it is not means only base of theory is not important. Practically, we have to find out that what exactly our site needs. Then sometimes what happens nowadays, when the builder purchases the land owner previously holding land may go for a lot of soil filling, uh, to, and these also need to investigate. The different use of soil is also there. Means if you wanted to go for frame structure, the investigation should means give you some of the answers to your required these questions. The type of footing is based on the soil investigation, and I think geotechnical engineers should suggest the type of footing. Means previously the whole job is of structural designer. So what we suggest as a designer for a good high rise building, not g plus 3 as Mr. Rao said, so not for small buildings but for high rise building. High rise means more than 10 stories or something. we need to incorporate a soil investigator, geotechnical engineer to help you out for deciding the foundation type, the foundation area, the contact area of means soil structure relationship, and the effect of this structure after your construction. So all these things we need to go as a part of investigation of soil. Many times we need to go for a dynamic um, machineries or dynamic structures on soil. So the parameters are different for this dynamic investigation load bearing. We have done a lot of work in different soils. Sometimes the whole site is under water, and this investigation should be very vigorous and find out exactly the settlement values and uniform settlement values and all these things. Sometimes we need to go for a black cotton soil or something, then we need to go for shrink swell ratios, and so the basic in addition to basic investigation, we need to ask for the additional reports or additional investigation or additional answer to our soils. And last but not the least, when you open out the site for open construction or for anything, you need to ask the soil expert to comply and validate the result given by the soil investigation report. So sometimes the soil person says that we have taken the sample and it is locally good, but in practice there may be some variation of the soil in many places. So I think these are the basic practical questions which we found everyday life. Thank you.
Okay. Yeah. Okay. So Dr. Jai Kumar Shukla has just joined with us. Yeah. Good evening.
Good evening. Good evening.
Yeah. Yeah. So any quick remarks on this before we get to the next discussion?
Yeah, I was, let's say, not available prior to Suhasji's discussion. But
Uh-huh.
let's say, from a geotechnical engineer's point of view, the
Hmm.
message is that there is no straightforward answer to any of the, let's say, site. Every site has a unique soil characteristic. What we can have it is the approach in the sense that for any site, if we take a few boreholes, maybe if we are really engaging a quality geotechnical investigation agency on which we can depend on, probably then we can optimize the number of boreholes. Let's say, uh, do not know the performance of the soil investigation agency, probably then we should have a more number of boreholes in our site. But this won't work for each and every site. That's why I said we should have an approach of identifying the uncertainties into the, let's say, the geotechnical parameters or the uncertainties into the subsoil strata below our site. And if we are confident or can identify those uncertainties, probably the design decision can be done or can be taken better. Uh, it can be addressed or during our design, the uncertainties which we have identified. But as I said, the structure engineer and geotechnical engineers must marry before the site progresses. It can come up, and if
Yeah,
that
sure.
is good and your partner is right, then probably there would be a happy life for even your customers as well. Otherwise, you will find a problem.
Right.
Yeah. Yes,
So,
perfectly said. Yeah.
yeah.
Yeah. So can I move to now Sandeep ji to share his quick perspective related to, let's say, the holistic approach about geotechnical investigation before we get into the discussion related to the scope of work?
Just one second. So So just highlighting and understanding, we do soil investigations, all consultants prescribe it, and it is delivered accordingly. And then we do have surprises, and the surprises are the pain areas, which leads at many times to divorces, as Mr. Jaykumar said, Dr. Jaykumar said. So coming to whether it's a construction project or a cricket, finally the ground conditions are governing. The captain of the winning team always decide what is the condition of the pitch. So based on that, he makes a decision whether to bat or bowl first. So accordingly, on a construction project, maybe building, industrial, or infra, and everything depends on the what is the ground conditions, and that is the pivot point in the complete success or failure of the project. So for all the stakeholders, it is very important why investigations are required. So understanding it generally involves, actually this had some animations, but just to get a brief of it, generally on the inception the investigations start, and as the investigations progress and once we have some surprises, there is a extensive review of cost, which is escalation in cost, where mitigating measures have to be taken, and these surprises eat away significant uh, time, resource for everyone. It's not just the consultant, it's the contractor and the principal employer also for a complete project. So maybe it's a builder with a contractor, also the consultant. So considering this, it gives an understanding about how the what is importance of investigations for the different stakeholders, uh, the clients, the consultants, and the contractors. Uh, GI for them, the client is mainly constituting the safety and the speed of investigations, and for design consultants, it's mainly the how the optimum designs can be achieved with the compliance to the codal provisions, and the contractor bottom line lies the profitability, how I can ensure profitability to come out of this ground. Sorry for the bad mismatched presentation, because some of them have got some had animations and I was not aware about it. So taking it further on, the investigation programs generally flow from the micro level to the meso to micro to macro level, at the different levels of investigation, starting from explorations, coming to testings, designing the foundations, execution of foundations, and finally the structures. So understanding at the basic level the strength parameters is quite significantly important for the all stakeholders. So what are the different kinds of rigs proposed? These are mainly calyx type rigs. These are quite uh, nostalgic, or rather ancient rigs which are being utilized. Then comes the hydraulic type of rigs. These are quite conventionally available. And current generation are the hydrostatic rigs, which are quite faster in drilling and give better progress, good core recoveries, and better for our project to ensure uh, economical foundations. So different type of foundations have different type of, these are common tests which are generally conducted onto the soil formation standard from SPT. Mr. Jayakumar can elaborate more about it. The SPT, the correction factors, the energy dissipations, how these are computed, and how these have been recently upgraded to the current levels. Then comes the undisturbed sampling, the packing of samples, dispatching, the quality of tubes. These are quite significant contributors to that. And lastly lies the uh, vein shear test, mainly to understand the low values of parameters, low values of the ground engineering studies. Coming down to the rock formations, these give us idea about the core recovery, RQD, all the aspects of the rock stratifications, which are quite significantly important, specifically when you're looking out for a deep-seated end-bearing pile foundations. These are the different kinds of field tests which are extensively carried out. The Spd test, which is as elaborated previously, is a simple driven tube at the end of the standard tube at the end of the standard drill string, which is impacted through a standard weight, through a standard drop. There are, of course, energy computations to ensure that the energy imparted to the split spoon sampler is within the permissible limit and can be utilized. Next comes is the SCPT or CPT. This is mainly utilized in the friction cohesionless as well as cohesive soils, mainly to understand the skin friction, frictional resistances, as well as the unconfined compressive strength, and as well as the pore water pressure measurements. Then comes the flat plate dialtometer, which involves pushing the plate into the ground, expandable plate. It is mounted with sensors. It measures the stress versus strain relationship, which is the elastic limit or the elasticity modulus of the stratifications. Next come the pressure meters, which are slightly for the better soils, where we compute similarly the stress strain relationships of the soils under different loading conditions and different lateral rate of loadings. Lastly is the vein shear test, what we saw it previously, where a string of vein is inserted into the soil, specifically with the very soft clays, cohesive soils. You can be visible in down south in Cochin or many places in Mumbai or in coastal areas in Gujarat, where the strengths are less than 25 kPa, 25 to 40 kPa. So going forward, these are different kinds of coring tools which are extensively used in specifically in rock coring. The single tube core barrel is a simple tube which has a bit at a cutting shoe at the end and driven from the drill string at the top. Next comes the double tube core barrel, which has a better version of a single tube. It supports the core sample as well as the better core recoveries obtained, where the inferences can be better. And then finally, last one is the triple tube, which specifically improves the quality of sampling, ensuring near 100% core recoveries. The better the quality of sample which is being implemented during the investigations, better the inferences or depend confidence of the geotechnical engineer, and its benefits get subsequently passed on to the structural consultants and further hierarchical progress. So it's very important that we invest in good quality investigation. So structurally, what is difference? Actually, this slide is a bit animated, but on the platform, I'm not able to display the animation. Basically, single tube core barrel ensures that the sample is just drilled through. Generally, while drilling process, you add water as a fluid and as an flushing medium. So the water directly hits the samples, and due to which it gets eroded in the drilling process. And it's very likely that you may lose the samples or the quality of samples, end up inferring as a poor quality rock for a good quality rock, or many times you cannot conclude anything out of it. Sometimes you conclude that even if it's with some kind of intermediate formations. Double tube is an improved version of single tube. It has a double tube concentric to each other. The flushing media passes between the interstitial gaps between the two tubes, and it's flushed at the bottom at the bit level, and it's discharged out. The samples has a lateral support, which is a swiveling tube, which ensures that its inner tubes remain stationary while the drilling is done by the exterior tube, and due to which the probability of getting better sample is significantly higher. In a triple tube, there is another split tube into this double tube and a change in design of the bits. It ensures that there is no contact of the flushing media with the sample, by way of which 100% core recovery is near guaranteed for the project. So these kinds of sampling can significantly improve reliability of investigation, the cost of foundations, even though it is costlier at least twice than the single tube. But certainly, you investigate a borehole with this single tube, and you might end up having a longer pile length if you investigate with a triple tube. So it's cost benefit analysis one has to do and take the decisions further. So in spite of having a better quality investigations, good quality investigation, surprises do arise. And how we have in our experience, how we have overcome these surprises and help the clients and the projects through. I'll just put up one or two case studies and we can take it further. So this is typically for a cable stay bridge in a coastal district of Goa, coastal state of Goa. The investigations were planned at the construction stages, and after completion of investigations, pile lengths were proposed and pile lengths were taken up depending as per the investigations planned. And when the piling commenced, it was observed that even the heaviest piling rigs were not able to achieve the required rock sockets, or they were not able to permeate through the sockets due to abrasive rock formations that were shallowly encountered and which were not visible in the geotechnical investigation. Subsequently, the contractor had to come back to the investigation stage, as I had shown in the first slide, which increased their cost. And we came into the picture. We did the investigations, and specifically in the formations where the rocks were completely weathered, completely fractured, not weathered, with near 0% RQD, we were able to give 100% RQ recoveries. Now, certainly this improved the confidence of the designers, and they were able to have premature terminations of sockets, and that saved them significantly cost of foundations and time of foundations which were required to be taken up. So the quality of investigations does significantly help while taking it forward. So availability of key learnings are generally good quality of equipments and availability of nearby stratifications greatly improves the confidence in the investigation programs. This is for a suburban buildings in Mumbai. It is about a floor plate area of about 500 square meters. It was a pile foundations were recommended by the GI agency. And similarly, we faced erratic stratifications at the site, and we had to curtail the pile foundations to open foundations, and we took it further. This was the kind of floor plate area with different boreholes were significantly high for a 500 square meter plot. 3 boreholes were planned for each of them. This was the kind of profile they had plotted. It indicated very poor rock at these stratifications and made the judgmental that yes, you can go in for pile foundations with such kind of poor recoveries, considering the variation in stratification. Similarly, out here also it was quite varying stratifications at rock at one of the boreholes at shallower levels and other at the deeper levels. So once the contractor started the piling for the works, he was not able to achieve these sockets, and he came back to the project proponents, stating that we will go, it's not possible, we have to change the type of foundations. The project was halfway through completed with some of the pile foundations. These were the typical pile cap layouts for which the piles were completed, and some of the piles they were not able to they were not able to extend up to the desired socket levels as proposed in the geotechnical investigation reports. So finally, to take a call, an open excavation was planned at both the building locations. One building hardly had few boreholes, few piles done. This was the first building. It depicted quite good rock formations, which was completely missed out in the boreholes. And next one was quite surprising. These arrows indicate the corners of the building. Some piles were completed, and it had a quite unique stratifications encountered, where we have a rock for the half part and missing half is missed out here, taking it below So no basements were proposed. So they had to build up the building from the bottom to the top, build up the foundations, and taking it forward. So finally, it was decided that being a government project, whatever pile foundations are completed, you adopt the pile foundations and integrate the foundations with considering a raft foundations at the founding level and construct it further. So this was the kind of final output for foundations. What they had to be planned, a raft had to be isolated. These piles were completed, and after that, a raft had to be planned, and both the things had to be integrated with stiff beams connecting the pile caps, ensuring the uniform behavior of the complete foundation systems. It was a ground plus 10 storage structure. So the learnings were rigidity to the investigation programs. Being a government project, you have to go by the book. They cannot deviate, you in spite of having the challenges. There is a need for having multiple techniques of investigations, and these has to be phased out in different patterns. I will skip this one, taking it forward. This was for a jetty project. We had done opportunity to do it at the both stages. Here we had a value addition. We had done the investigations at the pre-tender stages. The rock formations were mainly sandstone and limestone, and it is a unique characteristic of limestone formations that they depict extensive cavitated formations, and these cavitated formations pose significant hurdles while you are socketing your pile foundations or into it. So to understand and to integrate further, as we were involved in both the stages of investigations, like maybe pre-tender and the post-tender. During the post-tender for the contractors' investigations, we proposed them to utilize larger diameter of pile the boreholes, to obtain larger size core samples, gave us leverage of better core recovery and better inferences and shorter pile lengths. So a better investigation programs does improve significantly the cost of foundations and the time further required for it. So these were the kind of savings we had created for them. So coming to the surprises, how and why these surprises are, and how we can take an holistic approach to it. Challenges in geotechnical investigation lies, these are very point investigations. You get the point information, and we extend these point investigations between different points on a location, culminating into longitudinal profiles. But actually the profiles vary significantly between these two locations, and making it open for difficulties and open for risk later on. Moreover, geotechnical investigations can be classified as anomaly investigations because the ground conditions are certainly always heterogeneous, even though we qualify them as sometimes homogeneous, and varying with significantly dimensions and depth. So anomaly investigations are certainly taken in different approaches in different industries. If you go to metallurgy, it starts from non-invasive methods like UT, RT, and then invasive microscopic studies. If you go to medical sciences, medical industry, the anomaly is going from the symptomatic to radiology and to the invasive stages. But specifically, we engineers, especially the geotechnical engineers, we jump directly onto the geotechnical investigations. Moreover, all the other industries, what they are approaching, what we learned in our engineering days in surveys or topographic surveys, that the approach should be from broad to narrow. But unfortunately, in ground problems, we are taking it from narrow to the broad spectrum, where we investigate very narrow point and infer to the very broader areas. And similarly, what we have learned in the surveys that we need to move or investigate or assess from whole to part. This has been extensive shares. So coming to the investigations, I'm changing from the geotechnical to ground investigation. As per my analogy, my understanding, the investigations need to be done as a ground investigations, and these have 4 dimensions. And we are just exploring one dimension, that is geotechnical investigations, and I equate to it as a biopsy. The other 3 parameters, I call them as geoparameters. They are synonymous to our telephone networks, what we call as 4G, are least concerned or least connected. What are these other 3 parameters? These are mainly the geology, the geomorphology, and the geophysical characteristics. Unfortunately, the slides are not clear due to some animation. So these other 3 parameters, when you infer all the other 3 parameters, the geology, the geomorphology, and the geophysical characteristics, you are quite certain, the explorer is quite certain what is likely to be encountered, and the geotechnical investigations bus just becomes a confirmatory tool or ground truthing tool to assess it and to arrive and conclude it. Certainly, all the mathematical expressions and the mathematical inputs required for the structures come from geotechnical investigations, but the investigations get much more stronger and robust when they are coupled with the other 3G investigations comprising of geomorphology, geology, and geophysical investigations. The geophysical investigations significantly add value to it because they give continuous real-time line informations rather than the point informations. Once you have multiple line informations, you can develop 3-dimensional different profiles, and the uncertainty in these profiles are going to be the points of surprises where you can investigate and assess, and then accordingly you can plan your geotechnical studies further. Moreover, the geophysical investigations or the geology, other 3Gs, what we are postulating, I am proposing, the understanding about this would give us to quantify our geotechnical investigations, the number of boreholes you need to have for a specific site. Yes, I need here more boreholes. Yes, I need here lesser number of boreholes. Yes, the stratification is quite uniform and consistent in my geophysical model, so I can reduce my intensity of geotechnical investigation. So this kinds of leveraging can be done based on available knowledge and the available informations if all the 3 others G's are explored. So some of the case studies where we had utilized these all the 3Gs. It was for a steel plant where extensive boreholes were planned for the principal, and we completed the investigations. It was a large plot of about 1.9 by 2.5 kilometers and different facilities located at different places. And based on these investigations, we were able to significantly understand the stratifications what are encountered. These are the geophysical tools we had utilized, refraction, MASW, and based on these, we were able to understand the stratifications, how these are encountered, and taken it further for the assessments. So characteristics of a 4G model where we can have the what all tools can be utilized in different aspects. When you have flatlands with high plateau lands, all the things are quite linear and you can have a linear investigation program. When they are made up grounds, geophysical extensively have complex parameters as well as the geotechnical. The other 2 parameters are quite lenient, and one can have the investigations program focused on these two areas. When you're looking at river basin gorges, you will have to target all the other four parameters quite critically. If you're looking at a hill slopes or challenging geology, yes, all the parameters need to be assessed. Gradual linear terrains can explore geomorphology will be a critical parameter rather than the geotechnical parameter. So based on all these parameters, you can extensively de-risk the complete underground investigation process and the uncertainties into it. So it creates a significant savings to tune of 10 to 15% if the investigation is program is coupled with this 4G investigation stages, significantly reducing the probability of increase in cost and improving the ability to reduce the cost at the design stages. So with that, I will like to make a conclusion to my presentations and will be open for questions and other things.
Yeah. Thank you, Sandeep ji. So we have received immediate remark on this. It's a very interesting presentation and a new perspective for geotechnical investigation. So could you please share the presentation PDF if possible? Okay. Okay. So can I go to Dr. Jay Kumar Shukla that in his opinion, what will be the general approach for deciding the scope for geotechnical investigation?
I would say that particular should be based on the type of structure, the extent of, let's say, the area which need to be investigated, and then the intensity of loading which you need to, let's say, transfer from your superstructure to foundation. So usually it is recommended that we need to have a two-phase investigation. Two-phase in a terms of that if you know the area and some previous boreholes into around area, then you have some information related to that subsoil conditions. And if it is not available, probably you drill a few boreholes as a preliminary investigation, and then based on the outcome of those preliminary data, you will decide the let's say the additional number of boreholes and additional number of tests, because it's
Yes.
not necessary that at the beginning from zero date you have all the let's say the required number of tests to be listed out. So this flexibility, I think the structure engineering fraternity must understand that from the 00 date, probably it may not be possible to answer all the queries by taking a too much investigation. If you take that all the number of say boreholes and the investigation into this, definitely the investigation cost will be high. So better to phase it out into two phase. First phase would be a preliminary boreholes, and then second phase would be a much more detailed investigations in which the structure engineer and geotechnical engineer probably would work together to identify a few critical properties which will be then required for the design. That would be a better approach rather than one phase single phase investigation. If most of the time what I understand is happening is the client, or I would say the builder, or whoever is the developer, they directly approach a geotechnical engineer with some number of boreholes to be planned. So that 3-4 boreholes has been already drilled, and then the client will approach to structure engineer with all that three numbers of borehole data, and then ask him to produce a design based on the available information. Then there is no other cycle where the structure engineer can discuss with geotechnical engineer that they need some critical information into this zone, or if they have some doubt or some confusion regarding the properties, there is no way they can go back onto the field investigation and get the answer. So better probably is to find out two-phase investigations, and that will provide opportunity to interact, have some time. But client or a developer also must understand that they need to spend some time with geotechnical engineer as well as the structural engineer in an initial phase, so that the value engineering can be done.
Right, right. Yes, yes, Suhas bhai. Your mic is muted. Yeah.
Yes, as rightly said by Doctor, that it is necessary to meet before the investigation starts, and then we have to decide the line of action, the number of boreholes, the requirement of site. Again, sometimes the requirement of site is very different. Like suppose I have to go for to floor down the soil in a very sensitive soil where the rainwater is readily available and stays there for 2 or 3 months. So all these things are the data which is needed to share with the geological investigator, and then both of them should work together and find out the parameters and the approach to solve the problem. And this makes means spending little for investigation and consultant will save a lot of money in actual execution, and we have found in many cases there means like previously described the combination of pile and raft we have also done with this philosophy. Sometimes we found that the soil is correct, but while digging we found the problems, and again we have to ask for the geological investigator or geological engineer to wait about the work. So let us ask others and solve their problems also, I think.
Yes. Yes, so as rightly said, the investigation should be in two parts. One is preliminary, and then it is detailed one. But generally, in
Yeah.
the practice, it is only going in just only in a one investigation. And that's why I think all problems are arising with respect to scope of investigation, because it is not known, like what is the soil, what is the soil type, what is the strata, and what is the extent of investigation which would require. So now the question is coming on the screen. Kishore Behera has put up this question, like what could be the guide to finalize the number of boreholes, depth of boreholes for a structure. So even let's say for a preliminary investigation.
Dr. Shukla.
Yeah, what we are
Yeah,
looking at.
I think the preliminary guideline can be tentatively based on the type of your width of your foundation. So at least you need to investigate the 2 times or 2.5 times of your width of your raft or foundations below the deepest level of your foundation. So basically what happens at the preliminary stage, you might not be knowing that what the depth of foundation is going to be let's say finalized. So probably 3-4 meters or some particular data if available for the similar soil around it, you can finalize, and then the depth of foundation. But in a thumb rule, probably the 20 meter to 30 meter is let's say the right approach to investigate the preliminary, and based on the outcome of those, probably then the strengthening, either you need a higher or deeper depth borehole, or you need to have a specifically focused borehole for a shallower depth that can be decided. Usually 20-30 meters would produce you good information based on which you can take decision.
An assessment needs to be done for the vicinity structures. What are the existing vicinity structures and what are the type of foundations for that? That can be an initial guesstimate for it. Based on that, for stage one investigations can be planned. And stage one investigations, once planned, the output of few boreholes. And based on the output of few boreholes, after interaction with the with the structural consultant, probable type of foundations which are likely to be estimated can be concluded, and based on the further investigation can be concluded depending on the in these two stages. Rather than making it stages, it can be in between interaction between the structural consultant and the geotechnical consultant, who can comment the suitable type of foundations for the structure and the constructability point of view with the contractors. To measure the type of foundations specifically in the multi-storied buildings, the governing factor lies rather than the structural and the geotechnical consultant constructability and the challenges for the construction and how fast it can come out. At sometimes, many times I've seen that the while foundations are uneconomical or costlier, yet the proponents aggressively propagate for the pile foundations because they are able to come out of the ground faster rather than the open foundations.
Yes, yes, Umesh sir. This is the common question we are receiving, that how to finalize number of boreholes, depth of boreholes for a structure under consideration. Sorry, just a minute. Your mic is muted.
Yeah, it depends on kind of project.
Hmm.
Let's say when we are doing Ahmedabad Metro, uh, that was 95, I think, when we started planning it. Gujarat State Architects and Engineers Association is next to the, I think, Institute of Engineers near Law College. And they have wonderful laboratory, which then Kadiali used to look after it. Vijay Bhai Shah used to be the president of that association then. And when we planned our routes in Ahmedabad for a metro, first thing we did was I knew from Mehta, Tambe and others because a lot of good friends were there in Ahmedabad. Mahendra Bhai Mehta was there of VMS. Tambe was there. Dr. Bimal Patel was there. So we went to Kadiali and asked, and believe me, on the routes that we had planned metro will go, we got 63 sites data from them, and within about less than 4 hours. So the information was available. Similarly, when we were doing work in Kakinada, from the adjacent sites, lot of details were available. Or in Noida, or for anywhere else, whether in Malaysia or Moscow or anywhere else. So you get an initial data, you make an assumption which is certainly not accurate, but quite a few times we, based on this data, used to say that probably the bearing capacity or the bore log and things of that kind, like Kakinada, is 2.5 meters below the sea level, and it's a clay soil. And with the fluctuation, but it's only 1 meter in Kakinada, as when we did Kalpakam Atomic Power Plant also. You find that data is available, you identify, like when we did Vanakbori Thermal Power Station in Ahmedabad near Godra. Yeah, it's a fine, beautiful sand. So we expected 25 ton to 30 ton per square meter, and then we decided this is the depth of the borehole. And when the investigations were completed, we were not very much off. We had taken it as 25 30, and the actual bearing capacity came to around 35 ton per square meter. So one way is make an assumption, go ahead and decide, as Dr. Shukla talked about it. You get a size of the foundation, minimum 2.5 meters below the foundation, 2.5 times the size of the foundation, you'll have to go below and get the bore log to identify. And this is quite common, but quite a few times two agencies do not give the same reports or recommendations. Let me put it, because soil cannot change, so the bore log remains the same. So that's one area. Second, as Sandeep quite rightly said, is the flatness or the levelness of the ground, like Goa. The slopes are very high. Kerala, slopes are very high. Kurg, slopes are very high. But when it comes to Noida or Bangalore or Ahmedabad or Kolkata or any other place, it's very flat. It won't make much of a difference in terms of uh, trying to understand the slip circle failures of the soil or an impact of one foundation on the another. So you understand the nature of the project, what you need to do, what is the information that you require as a designer of the project, and then have a good relation with other teammates of yours, because ultimately you work as a team. Even like a geo investigation, you require concrete technologies in the team in whom you can believe. Because excuses everybody give why the cracks are. But what you need is, I don't want a crack, so you tell me what is to be done. So teamwork is a necessity. Your team, key players in the team become a very important part. Like we had this problem in BL Taloja. When the plates were ordered, they were all laminated. It could have probably uh, could be fatal when you design it with the plate which are laminated, because they'll open up. So I think you require people in a team. You need to understand the project. Like when we talk about piles, and when we did the work in Johor Bahru Strait for Malaysia Electricity Board, that was around 75 or 76, the negative skin friction that would come in the soil, and what is the capacity of pile. Or when we did it in Krishnarajpatnam port, where we were not really looking at the negative skin friction so much. But every time being conservative with this soil investigation expert, we had to literally fight. This pile capacity, in my opinion, will take 300 tons. Why are you restricting to 120 tons? Then it started bargaining. Sir, 190 tons, sir, 205 tons, sir. Then ultimately at 290 tons, he said, I will not sign any report beyond 290 tons. But as Sandeep said, it has an impact, or as Suhas also talked about it, because from 120 tons to 300 tons is 2.5 times. So your number of piles reduced to 40%. Going by even by the linear theory, time required is 40%. Going by the linear theory, even the machinery to be deployed at the site is 40%. I'm talking as a linear theory, and really you need to work back and the movement and other things. But it can play a tremendous role where if the data is available, and data is always a power. And once you have a data, we as an engineer, we know how to crunch the numbers. And that's our specialty. We understand numbers extremely well, number of parameters, even if they exceed, quite a few times you don't require a computer to identify and assimilate these numbers. So I think, as rightly said, if the land is flat, like Noida, where you find the soil almost similar, borelocks, go ahead and take borelog at 50 meters. Why 20 meters and 30 meters? I don't think so. There's necessity. Maybe in between, take one intermittent borehole to satisfy yourself that the soil really doesn't vary so much. But if you're coming to Goa, I would say why not 15 meters? Because that land is such. Or when we did some work in Mangalore, we had a similar problem. So I think every consultant needs to understand the project, requirement of a project, what would it mean, and hence what are the parameters those are required. Because ultimately, as a consultant, you are signing the papers. And that's the faith the client has in you. And you need to rise to that faith. And that's the pressure. And hence, a consultant has to spend time to understand the project, impact of that, what kind of land, and then decide what kind of test I want. And then depend upon the expertise and specialization of the teammate to advise you how to go about it. This is what I would say. And I don't think there can be a military rule saying that by say the so आदमी 5 कदम आगे. It cannot be like that. It needs to be defined. Yes, sir.
Yes. Yes, Sandeep. Sunil Kumar is telling that we generally use double tube for rock and triple tube for OC clays.
Places when you're looking wearing drilling in very poor rock quality of rocks, rather I'm saying with the weathering grade and effect of it, we use triple tube core barrels also. The benefit of using triple tube core barrels is that the water doesn't touch the sample, so the chances of probability of loss due to churning action, rotating action of the core barrels and the drilling tools is not so high in case of triple tube core barrels.
Yes. Yes. Tanuja Singh is telling that pile with raft can lead to differential settlement. How to take care of that? I think she's talking about few foundations are supported on pile, and let's say there is one raft foundation.
Generally, what we are doing, we are um, designing the piles when we have already go for pile. So instead of giving pile cap, we are combining this pile with raft, and partial load is transferred through the pile, and rest of the load is transferred to the raft. Each and every foundation should be treated individually for settlement, and the settlement value should be equally done for all the cases. Means suppose there is only raft, even the your settlement means pressure design should be similar to the uh, pile and raft foundation. So it should be equally settled. The unequal settlement should be avoided for such things. So we can model like that also.
Yeah, and Sandeep ji, I am also thinking that for this area also close interface is required between geotechnical and structural engineer. Let's say
Certainly.
certain foundations are provided. Now, the settlement value which is given in the soil report, that is considering, let's say, only one type of foundation. But now, let's say if structure is sitting on a different kind of a foundation or different types of foundation with different sizes altogether, then I think the close interface is required instead of just merely picking a value from the soil report, right?
Yeah, because what happens is that, like what I had shared the example in the presentation, it
Mm,
was a hybrid foundation within the single building. Few of them footings sitting on the pipe foundations and few of them on the raft. So
mm,
suddenly, with the raft, subgrade modulus is going to come into play, and
yes.
with pile foundations, it's going to be the general ultimate settlements. It's going to be there.
Yes.
So matching up with that is a challenge.
Yes.
Uh, Either we have to increase the stiffness by providing stronger rigid connections between the pile cap and the other raft portion,
Mm,
or provide some amount of flexibility within the structure where
mm,
it has been accounted for by providing some kind of expansion joints or at the structure level, interface level.
mm,
So
mm.
that again comes up with the permissions from the architects, operational people, whether they are going to allow such kind of hindrances to independently for the structure to independently behave.
Yes. Sunil Kumar is telling that for big projects, we generally perform preliminary and detailed soil investigation separately. But for small project, it is usually it is one soil investigation, which is detailed one.
So basically, what we can do is that I don't know what size you are visualizing with these small investigation projects. Even if
Mm,
you are saying like say 4 to 5 boreholes, you can complete 2 boreholes, come back to the structural consultant, discuss the probable type of foundations, what are there and what can be done, and again advise to the geotechnical investigation team to further plan it accordingly as per the conclusions of the discussions with the structural consultants, the type of foundations we are proposing, or maybe increase the depth of boreholes at that point of time, or increase the number of boreholes, and then take it forward.
yes, yes. Bharat Kumar is telling, sir, I have three bore logs which are drilled 5 meters apart at 3 meters depth. and the bearing capacity available is 8.5 ton per square meter, 8.8 ton per square meter, and 9 tons per square meter for 3 boreholes. Which one I have to adopt for the design?
For design, I think the minimum should be adopted.
Yeah.
That is the right answer. How can you take the average? You cannot take average. Weakest link is a failure.
Yeah.
I would say
But
go
I
ahead and do it by 9 tons because the variation is so small. There's
Hmm.
nothing to talk about it.
Technically, on a practical scale, it's not going to be much significantly different. With 1 ton
yeah,
per meter square, the building should not collapse. You have
Hmm.
right.
sufficient redundancy in the designs to
Yeah.
accommodate a differential bearing capacity of one
There
ton
is
per meter square.
all designs like other day when I was talking to Yuval Kunte from Pune, who is on NDT, bureaucrat. After all, you use only 25% of the concrete strength. It is an acceptable acceptance criteria. So when you cast an M20 concrete, you are utilizing only 5 newtons. When the Q ultimate in the soil is divided either by 2.5 or 3 to get the working one. So I think these small ones, I don't think you should be skinning your teeth and splitting your hair on trying to be an accountant. Look at the number of the right decimal or left of the decimal. We should stop at that.
Yeah.
Your job is not accountant.
Yeah.
Number
What
But the
is
invest
important out here is that understanding the numerical. When I'm saying uh, some value at some per square meter, one needs to understand or visualize that value. Luckily, I having a laboratory and I've been there involved. Uh, there used to be some pressure pumps and it used to be there. I used to hold a finger or thumb onto the pump and measure it simultaneously onto the pressure gauge. What my thumb can resist? It is 2 kg or a 3 kg or 4 kg. So with that intensity, one can visualize what is going to be the effect onto the ground. So
right.
it's
No, I
very
agree.
important, as Sir said, that it's not accounting practice that you have to tally the numbers and conclude it, but it's the visualization when we are saying it 25 kPa or 40 kPa or 100 kPa. What is going to be really 100 kPa like?
No,
Yes.
I'll tell you honestly, we used to have this problem. Let's say we design our residential floors for 200 kg per square meter or 2 kilonewton per square meter, those were conversant with SI. So we had this big problem. I have this sofa, I have this Almera standing. Then I stood on in front of him. I stood on one leg, scratching my head, and then said, I weigh 100 kg, my 1 foot is 1 foot long. My foot width is 100 mm. So I'm at the moment generating 3 ton per square meter stress below my foot, and you're designing slab only for 200 kgs. Does that mean the slab is going to collapse? I'm not allowed to scratch my head standing on 1 foot in my house. So what Sandeep said is right. Even in the soil on the site, I should stand on 1 foot. See, when I stand on 1 foot, I generate 3 tons per square meter pressure. What is the dent that you get? Is it, can you see it to the eyes? In a good soil, you don't. In a slightly medium or a soft clay, you might see 1 or 2 or 3 mm. So I think quite a few times we need to understand Terzagi also. When Terzagi was, he started much earlier when these kind of equipments were not there, but ultimately he just took one peg to decide how he is going to design the machine foundation, and that's what Terzagi was. I think when we
But
try to skin our teeth and split our hair, then we try to kill ourselves, making an engineering into a retina nerve operations. I think we must stop this.
one more question to me. The investigation of 5 meter apart is only 3 meter. So the depth of what is the depth of foundation? What is the width of foundation? Why it is only for 3 meter? That is also a question. Suppose to any structure, if I go 1.5 meter below, so the foundation width is very less. So you need only 3 meter to understand the pressure bump. I don't know what sort of structure you are having with all these three borelocks.
It's like earlier practices where people used to make a pit of 1 meter by 1 meter, maybe 2 meters deep, because they could climb out very easily, maybe with a ladder. So probably he has been generous of going 3 meters. He had a longer ladder. But I think the concept still remains of 1 meter by 1 meter pit to understand the soil. And probably somebody would have collected this disturbed sample or otherwise and get it to get a feel of what it could be. It's a very common practice. I don't know now. When I used to live in Bombay 50 years back, all the consultants, whether it was Maimtura, Nene, or Char, all those big people, eh, what is there? SBC, Bombay, sand, 25 ton per square meter. Same thing was in Goa also. I'm sure it was there in Gujarat also. अरे શું થયું બસ sand છે ને લગા લો 30 ton per square meter. This was quite a common practice. Bangalore was
Right.
like that. Good soil. Just put 1 meter foundation. They don't even talk about the load nor SBC also.
Right, sir.
I think it's a very common thing. As it develops, I'm sure it will be improving. I must say
Right.
that when I passed my BE, soil mechanics was not a separate subject. It was part of the geology. 60
Yeah.
marks for geology and 40 marks for soil mechanics. It was not a separate subject like what you are taught today. We don't bother about soil mechanics, study geology and you'll pass. Don't because 40 marks was only soil mechanics and passing was 40 marks. No. We had to study geology to pass. So I think
Right.
we have come a long way in last 60 years, where some lot of importance has been given to soil investigation, which was not there at all, and that is what we need to appreciate. I think. Just,
Yeah, Rajan is asking, as per IS code, what is the depth of borehole required for a multi-storied building of G plus 10 floors?
Generally,
Rajan,
what is
the
the type
ISO
of foundation anticipated, the size of building? These are the two
Yes.
governing criteria. If there is open footing or open foundations, there are likely to be better solutions.
Hmm.
Then at least two-third the width of foundation below the foundation founding strata will be a good option.
Yes.
Otherwise, if you're going in for pile foundations, at least initial estimates of pile depths, it should go beyond two-third depth below the initial estimate of pile depths.
one possible way of looking at it as Rajan, if it is a residential building, normally including walls, the loads would be around 1 ton per square meter, including the self weight of the slab, finish, and the live weight, and the wall. On residential buildings, very rarely the column spans exceed between 4 and 6 meters. So if I take a column takes a load of 24 tons per floor into 10 floors, 240 tons, and I assume 24 tons per square meter as a bearing capacity, I will get 10 meters foundation. Square root of that is 3.3 meters. 3.3 into 2.5 would be roughly about 8 meters plus 1.5 meters. So I think you should take 10 meters minimum depth of borehole, which
We
can get
generally
correct.
go for 12 to 15 meter in Baroda.
Agree.
In Vadodara, we
Agree.
go for 12 to 15 meter. Or nowadays, for basement and all this, we are going for at least 30 meters sometimes.
Agree. But if it is to be commercial building, this 1 ton would become 1.5 tons.
Sir,
That means
the spans we are taking more than 10 meters sometimes, 10 by
you,
8 and all this.
I
So the
agree. I
foundation
mean, these
sizes
are
are
some. I agree,
higher.
Suhas. I'm trying to tell Rajan is
Yeah,
make this assumption, come
yeah,
to certain numbers,
yeah.
and you are not justifying that this is right or otherwise, but you are setting a path to investigation.
Right.
And with this, you will get a fairly good idea of what is the depth of borehole that you need. There could be surprises. I'm not saying that there won't be surprises.
Twice the maximum width of foundation, at least he has to go below the basic foundation
Sure.
level.
Yeah, you take normally 1.5 meters below the ground level if there are no basement, if there's a basement. That plus 2.5 times the width of foundation you estimate based on this load should be the depth of borehole.
Yes, yes.
That is
True.
what the things are. And hence I'm saying residential building, go ahead with 1 ton per square meter to calculate the
Yeah,
size of foundation.
that is true.
Commercial
That is
building, go ahead with 1.5 ton per square meter. There are certain areas like when you have cold storages or nowadays printing presses have improved. But we used to take 2.5 ton per square meter, like paper mills, where you store the paper. The load on the slab can be 3 ton per square meter. So obviously you generate your own thumb rules and that will give you a path to identify what is to be asked for. That is the point that I'm trying to make.
again,
The
IS code has no specific value given in IS code. I don't
IS
think
code
that.
is written by us, for us, by us. I was a part of NBC. NBC 2015. I was a part of it. So I understand IS code quite well. And hence, I
Yes.
think we as an engineers don't write to BIS because having been there sitting on the committee when MBC was being formed for almost 7, 8 years, Dr. Vishweshwarya, Suresh, myself, Sanjay Pant, and all of us, we don't write. But after the code comes back, then we say this is not there and that is not there. But believe me, even if you write a postcard, in the meeting it is considered. You don't require an acknowledgement. You just send a
Right.
mail to Sanjay Pant or any person, and it will be considered. I'm not saying that it will be adopted because for that you need to justify. There has to be enough research and so many things to justify it. Anyway, that's beside the point. So the IS code is by us for us. So I don't think IS code is that silent. We can change. And first 3 pages of all codes write that if we can prove you need not follow code. Read the first 3 pages of any code. Just read it. Yes, sir.
Yeah. Okay, Rutuja is asking, sir, please, if possible, can you elaborate a little bit from type of structure or loading? How can we decide the depth and number of boreholes? I think you have already detailed out, right? This approach, like how we can decide based on type of structure and the type of loading.
Right.
Okay, Rajan is putting one more point that how you recommended the suitable foundation based on borehole slash n value results. Sandeep ji. Yeah.
Suitable foundations, we'll have to arrive at what are the laboratory test results if you're looking at the soil foundations or soil formations. What is the C5 values, what are the consolidation parameters, what is the anticipated settlements, considering the size of adopting a tentative size of foundations, and that would be the horizon. Based on n values, these would be based on what kind of stratifications and the it is encountering, whether it is cohesionless or cohesive or C5 soils. Based on that, we'll have to adopt the C5 values as per IS 6043, and then based on that, we have to arrive at the foundation depths. IS standards have there. IS standards give a good proper measures for that, and based on that, we have to arrive.
Yes.
I also feel when you are in charge of a project, you need to take a call whether you want to engage a special agency or not, what is the time frame, or otherwise, because it will make a lot of difference in terms of a project. Having dealt with projects, there was some very conscious decision what we had to take. I remember at least in a couple of cases, we decided we will not use files, we will use raft. For a simpler reason, we had to go on the project. Whereas when you do a flyover, the soil investigation very clearly indicates that open foundation is good thing to do. Yeah, but the amount of harassment it causes the public in terms of exposure, excavation done for the foundation. So we have said no, you go by piling because it will cause the minimum hindrance to the public. So it depends upon the focus for whom you are delivering with. And there cannot be a single uh, box like reasoning that this is what it is, this is what it is, this is what it is. And the cost is not necessarily in terms of rupee. Cost is in terms of the nuisance value to the society. The cost is the inconvenience caused or the project delayed. So I think apart from the technical part of it, whatever we are talking about, the values, what are there, where we can work out the economics in terms of rupee and pi and talk about what cost is. But is that the best? Not necessary. So as an engineer, where you're holistically, when you try to look at it as a project, I think you need to look at it and take a decision for what it is. I remember when I did the optimization study, because I'm basically a structural engineer. I'm interested in soil investigations and soil mechanics. I'm also interested in hydraulics. I love hydraulics as much as I love structures. So when we did the optimization study for a circulatory water system, we found that the auxiliary units were consuming very high power. So I decided to increase the diameter of pipe from 2150 to 2650 so that the auxiliary power consumption comes down and the cost was going up. And then I convinced the clients saying that please understand, even if you have generating 1200 gigawatt power plant, even at half percent, you just imagine it's 6 megawatt, 24 bar 7, 30 years. What is the revenue that you are getting? So why can't you sanction this money? And this was sanctioned in 75 and this was adopted internationally. So I don't think engineer's job is to understand engineering, no doubt about it. But engineer's job is also to see that how the society gets benefited and what does it mean. And hence, there cannot be only a longitudinal direction thinking. There can be a lateral thinking also, and you need to withdraw if the path is not meeting your time. This is what my opinion.
Yes.
I fully agree with you, sir.
Yes. Great.
So people, basically builders wanted to economize only on foundation because everybody knows the superstructure cost and they don't want to bury their money in soil. So
Agree.
somehow they pressurize the structural designer not to spend more in structure foundation. And this is the fight starts from this point
I
that
agree.
as a designer you want
They
good
consider
foundation.
this as a lost cost. Lost
Yeah,
cost.
yeah,
Yeah, but
yes,
ultimately, he's the boss. Those who can eat the chicken and digest it, go ahead and eat it. Person like me who is a vegetarian is quite happy with curds rice. And I don't bother about chicken.
right.
You decide.
This,
Then builders are
this
not
is
my
a
lord.
yeah.
Huh?
This,
Because I
this
never
general
worked for unregistered people because our office, I've been in practice for quite some time, more than 50 years. And we are very clear. Our logo was, if owner is not the user of premises, you cannot be our client. So government were ruled out. Really, the question does not arise. They were never the owner, never the user. At least government was owner, they were not user. They were partially true. So only corporate and industrial sectors and projects like this, where the owner and users were the same, then they appreciate what you're doing. Otherwise, they don't appreciate what you talked about. Suhas Bhai was right. मुंबई में प्रैक्टिस चलता था देन अब प्लम्बिंग 5,000 रुपया टॉयलेट का उसके आगे नहीं करना है तो उसमें जितना पाइप आता है उतना लगाओ उसमें जितना फॉसेट आता है वो लगाओ उसमें जितना टाइल्स आता है वो लगाओ भाड़ में गई दुनिया नहीं नहीं दुखी मन मेरे सुनो मेरा कहना जहां नहीं कहना वहां नहीं रहना anyway,
Yes.
sorry for deviation.
Yeah. Yes. Sandeep ji, for you, what should be the minimum value of CR and RQD to rest the foundation on rock?
CR values, anything between, if you are laying the foundations open on rock, you need to, these will be mostly open foundations. If you are looking at, when I'm saying these foundations on rock, I'm assuming these are going to be foundations on, open foundations on rock formations. For open foundations on rock formations, there is an IS, I missed the number for the IS, but specifically for foundations of rock, there is an IS standard which prescribes it and details the open foundations on rock. As far as CR and RQD ranges, if you're looking with the pile foundations, yes, you need to look at it. If you have the RQD, you need to assess the UCS value, and based on UCS value, you can arrive at the bearing capacity at that specific level. And based on that, you can take the base resistance of it and the 10% of skin fracture, and then plan the foundations.
Okay, so we have already crossed more than 1.5 hours of time. It's around 8:40. So let's take this last question and then we can close. Ganesh is asking what type of foundation will be more suitable in case of residential building project, which is G+4 with the base floor area around that's a 185 square meter, with subsurface as a black cotton soil strata, which is high swelling and shrinking in nature, up to depth of 5 meter. So whether pile foundation up to depth below the soil strata or footing with ground improvement should be explored.
So for such kind of problems, is the excavation possible up to 5 meters? This is one of the questions. Is there any water table likely to be encountered till you are excavating up to 5 meters? This is one of the aspects you have to consider. Secondly, one is ideally it would be stabilizing by different methods, measures like lime stabilization or cement. I don't feel so it's economical, but lime stabilizations are extensively utilized. And thirdly, pile foundations, so especially the underream pile foundations of 6 to 7 meters, should be more than sufficient for such kind of structures, because the loads are not going to be significantly large considering ground+4 structure, and this E value is quite significantly large enough. Only thing is that you have to overcome the swelling characteristics. For the swelling characteristics, we need to assess these aspects. Secondly, you will have to take care about the grade filling, specifically the plinth filling what we are looking at. This will be very vulnerable to swelling, so it is very likely that it damages the floorings at the ground floor level. So for that purposes, we will have to look out for improvements like lime stabilization or replacement by CNS material.
In
CNS is
addition to this,
basically non-swelling material.
yes, in addition to this, I can also suggest the peripheral area should also be taken care. Just like inside the plinth, also some area of plinth protection or outside the plinth should be filled with the sand or some non-cohesive soil. But yes, pile foundation is good and underrim pile is also good. But sometimes what happened is this. I am sharing my one of the experience. The 5 meter is okay. The pile is good, but the bulb is collapsed after five meter of depth because it is not a black cotton soil. So in such case, what to do? Means
Yeah,
if I go for 7 meter or 8 meter, my bulb
Okay.
is at bottom and it is not forming properly because it is not in black cotton soil. So it collapsed. So I take out some of the pile which is already casted with some equipment, and I found that there is no good bulb format in such soils. So this is a complex problem where your upper level is black cotton and bottom level is normal soil or non-cohesive soil.
See,
I agree with you. Sorry, go ahead, Sandeep.
yeah, please, sir, you can go ahead. You can say, I'll come down to that.
Yeah. I was just thinking, what was talked about the collapse. Yes, it depends upon black cotton soil's characteristic when you make a bulb under impiles essentially, and that under impile essentially arrests the uplift because of the swelling pressure. But if that bulb was not to form, the transfer of load because of cohesion, load transfer would still take place.
Okay.
That was one area where Sandeep can correct me, but that's the because what you said is right. Sometimes it does happen like that. Second, we have used uh, you allow the swelling pressure to come in, like Sandeep talked about plinth filling. What we did was we created a hollowness in the brick, like rat trap bond bricks, which Lottie Baker was using. So we filled up with the hollows so that the soil is allowed to swell. You don't restrict it. The moment you restrict something, then the
Yeah.
question of force comes in. If you allow the movement, the force does not come in because it's not the settlement that we are talking about. It is the uplift because of the swelling pressure that we are talking about. Even a geosynthetics played very well. And we found that on a larger scale, when you design, because Sandeep asked about open foundation, but if you really take it as an open foundation um, and use geosynthetics with a wider tapes coming in, it does work extremely well. I just thought I'll share my thoughts. My knowledge level is not as high as yours, both put to. I'm too small a man on this field. But this has worked extremely well because in Cochin, when we did MPDA, Marine Product Export Development Council, we have used 46-meter length of precast piles because Cochin is known for very soft clays. Some areas is stiff clay, same as in eastern coast also some part. So you find that uh, it does work with the black cotton soil. You allow its movement. If you allow its movement, or lime fractures like 1:4 addition does stabilize, but I'm not very sure uh, what is the life cycle of it in terms of leaching. That's not the area that I'm very well conversant with it. Over. That's what I thought I'll share. Yes, sir.
Yes. Okay.
Sandeep wanted to say.
Yeah, Sandeep ji.
Specifically, the question Suhas sir has raised is about understanding how the bulb can be insured or how can we install the bulb again. Uh, Bulb is a challenge in itself because if it's cohesive soil, you can develop the bulb, but if in case it's in the sandy soil,
It cannot.
generating bulb is a challenge in itself. In that
But you
case,
don't require also.
pardon?
Mhm.
You don't require also.
Yeah, that is a there. Some extent, we certainly, but some amount of tension capacity needs to be developed so that at least the uplift friction component can be taken care of and the swelling characteristics can be resisted. A pile length will have to be increased in that such cases
Yes,
based on
yes. Yes, we did like that. We increased the pile length and did without bulb because, as sir says, there is no use when you are entering into a non-cohesive soil.
Correct.
So formation is also difficult. So we increase the length of pile, and only friction of pile is asserted to
True.
resist the load.
I agree with you.
Yeah.
I think this is sufficient, no?
Yes.
To
Yes.
Ganesh sir.
Last question, Sandeep, for you. Like in one of the soil report, it is reported that n value for a particular depth is zero value. So what does it indicate?
Zero कैसे हो सकता
it's very soft soil. Even if you Less than 10 kPa must be the soil. Even if you put something onto it, it will go down.
Mm,
It's very soft soil basically, slushy soils.
mm, mm.
If
True, it
you
happens in a marine soft clay
very
or
soft
some of
marine
the
clay.
areas. Marine soft clay is very common. In a bank of the creeks, it's quite a few times when you get a marshy land, uh, it the moisture level or the water level is so high, your N value tends to zero, but not necessarily zero because it really doesn't have the shear resistance at all.
It's basically
It
water content is more than the liquid limit of the clays.
I
This is
agree
quite
with you.
predominant in the coastal areas in Mumbai, in Uran, JNPT. If you go in the Gujarat side, it's quite common in Kandla,
Yeah, yeah.
uh,
True.
Dahej,
The edge.
and
The age is very common.
then it is also common in Cochin. Cochin has about 25 meters of soft marine clay
Okay.
extensively. So these
And
formations are encountered. Specific characteristics is like the water content in the soil is more than
Very high.
120%, 130%.
I agree with you.
Yeah.
Then only you can get zero value. Then I think you should forget Newton's law and use Archimedes principle.
Okay. Okay, great. Okay, so still
That
there
would
are
be
a
a
few
eureka
points.
moment for everyone.
Yeah.
Okay.
Yeah, okay. So still there are a few points coming up. So we'll request all online participants to share their comments. Maybe whenever this video is published on YouTube, you can publish your, or let's say post your comments on this stream. And again, we may attempt to answer the same after collating the details from it. And we will be having subsequent sessions related to interpretation of soil report, etc. So that's what we are planning. So your feedback is also welcome on the email address, which was just flashed before a few minutes. You can share your feedback, or let's say your requirement on which we might have this kind of a live technical discussions in the future. Okay, so with this, we are very much thankful of all our entire expert team for sharing their insight on this scope of geotechnical investigation. Okay, and we are also thankful of all online participants for raising this very important questions. Okay, so with this, we are closing this session now. Okay, so thank you all once again. Good night.
Bye. Bye.
Thank you. Good
Bye.
night. Good night.
Bye.